All right. Whoops. Wait. I think some part of it is, yeah, not displaying. Maybe. Better. Okay. So hi everyone. I'm Gauthier, co-founder of Suzaku, and as Michael said, we have been working in the validator management area for a while because we are building a decentralization hub for Avalanche layer 1s. So helping those layer 1s get connected with node operators on one side that will run the infrastructure and effectively decentralize the network at a hardware level, and on the other side, stakers who will commit collateral to secure those networks. And today I will talk a bit more about the architecture of different types of validator management, and especially how ACP-99 basically standardizes the way a smart contract can manage a validator set on the P chain. So I think Michael already went into that. Maybe some people joined the room, I don't know. So I will briefly discuss this still. When you create an Avalanche layer 1, first of all, you still create a subnet today. So this will be this subnet creation will happen on the P chain. That is the registry chain where all the validators are registered on an Avalanche L1. Oh, sorry, on Avalanche. Create the subnet, then you create a blockchain, probably an EVM chain today, and then you will convert your subnet to an L1. Michael, talked about the transactions that are needed to do that, and then basically when you do that, you will say, okay, there is one address on one of the chain of the Avalanche network that will be my validator manager contract. And so this contract will be able to emit transactions, to emit messages that will then modify the validator set on the P chain side. So before ACP-77, ACP-99, we were in a proof authority way most of the times. The validator set is managed by control keys, and now we have basically unlimited possibilities to define new security models, and I will show in this talk how we can be very creative with that. Whoops. Also, it was one of the questions in the audience in the last talk, but one question that you will have when transitioning to an L1 is where do you deploy the validator set manager contract? Validator manager contract. So two possibilities. On the L1 itself, you will have full sovereignty, so you don't depend on the C chain, and you can directly communicate from the validator manager contract to the P chain. But then it's a bit dangerous because even after bootstrapping the validator set, if you end up decentralizing the validator set and you don't have the full control over it, and some validators, for some reason, get rogue or stop signing messages. And if those validators represent more than 33% basically of the network, you basically cannot change the validator set anymore, and your network may be halted forever. So a bit sensitive. So for early stage, let's say, and for early stage chains and chains that still want to decentralize, you can go on the C chain side, basically. Another advantage of the C chain is that most of the ERC20 tokens that are created on Avalanche are created on the C chain. And so they are native there, so it's a bit easier for all the staking flow. And as for the implementations, we have to date multiple implementations, mostly from Avalabs, who have the POA validator manager, POS validator manager in V1, and their counterpart in V2. So V2 actually was released very recently and is implementing ACP-99 effectively. Before that, it was a non-standardized, basically, implementation. And so I'll show the architecture later, but basically, for POA, blockchain is a single validator manager with an owner that triggers validator set changes. And for POS, it's a staking manager that can either be a native token staking manager. So this will mostly be if you're deploying the validator manager contracts on your L1, then you will use the native token of the chain for staking. And otherwise, an ERC20 token staking manager. If you're deploying the validator manager on the C chain, then the ERC20 might be your native token of the L1, and then you use this as an ERC20 for staking. And we also have deployed at Suzaku, developed at Suzaku, the Balancer Validator Manager, which is an in-between. I'll explain how it works. And as Michael mentioned, there's also like the Cocknet team who developed one, and Beam team also have some implementation of the Validator Manager contract. So this is ACP-99, and like the overall architecture. Basically, ACP-99 focuses on standardizing the right part of this, the left part, sorry, of this slide, and so it defines some functions that any validator manager should have in order to communicate with the P-chain. And so you have initialized validator set to really bootstrap your network and set the very first validators of your network, complete validator registration, complete validator removal, complete validator weight update, and the initiate of these transactions as counterparts. And so by defining this standard, basically it makes it very simple for any team to implement their own validator manager on top. So on top of that, you have the validator manager, which basically adds some permissions here. So you see that only owner are applied. The only owner modifier is applied to all the different functions. This is good. So if you're doing proof of authority, you can just stop here. And as an owner of this validator manager, you will maybe use a multisig for a multisig signature wallet, and so you will issue transactions from there, or an admin wallet simply EOA. If you want to move a bit further, you will plug on top a staking manager, and this is how Avalanche does it basically. So ACP-99 manager is the very base as an abstract contract validator manager, and then the owner of the validator manager who can trigger all the different transactions. And those will trigger only if people stake the right amount of ERC20 tokens. For example, if we're talking about an ERC token staking manager. So first implementation of ACP-99 is here from Avalanche, and then I will go into details about how we do things on Suzaku's side, what we developed, which is the Balancer Validator Manager, to also showcase how we can get very creative in managing validator sets from here. So with Suzaku, we think that most of the change will start proof of authority because it's the easiest way to kind of bootstrap, and also adapts to the very first stages in terms of adoption of a chain. When you're putting your product out there, you're waiting for traction and product market fit before actually thinking about how I'm going to decentralize, how am I going to incentivize the validators and the stakers of my chain. So very first step, the L1 team manages validator through POA validator manager contract and sets the weights of each validator. And then this is where we introduce the Balancer Validator Manager, which is our implementation of that we plugged on top of ACP-99. And with this balancer, basically, you're going to be able to plug in multiple security modules. So you will migrate over the validator set that you have in the first phase to POA Validator Manager security module. The L1 team will still be able basically to manage these POA validators the same way they were doing before. And our POA Validator Manager is compatible with all the Avalanche tooling, so you can use like the CLI the same way you were doing with the Avalanche implementation. So nothing changes on there. But we add something in between, which will enable you to start decentralizing your network, basically. And in our case, what we're interested in is using Suzaku for all the staking flows. So Suzaku, I will talk about it a bit later in details. But basically, we handle a lot of things on the Suzaku protocol side, and we have a middleware that will translate all the staking that happens on Suzaku to actual changes in the validator set. So you can define, prerequisites in the native token staking, in restaking as well. So you can say a validator has to have at least some amount of BTC dedicated to it, and at least some amount of the L1 native token dedicated to it at the same time. If this is if the requirements are filled, then an operator can spin up a validator through the Suzaku middleware, and you basically end up with two subsets of validators: one that is still managed by proof of authority, and then one that is managed by proof of stake. And the way that that we control everything is that we set a maximum total weight that can be managed by each of those security models. So here, for example, we say maximum total weight for the POA part is 1,000, can never go above that. And here, maximum total weight of the POS party is, 1,000 as well. But we start with 200 because validators are just starting to come in to this network and getting delegations and spinning up. And then as you evolve, your L1 gains traction, users, and incentives for your validators, you can modulate the weights allocated to each part, right? So you shrink down the POA set, and you increase the POS total weight of your network. And eventually you end up with a fully permissionless L1 that will only be able to, people will only be able to manage the validator set through Suzaku in this case. But by the way, the validator manager can also work with other mechanisms. So we could also, envision using it for transitioning between a regular, let's say, POA and a regular POS contract. Security module. And once you're, happy with the state, you can also just throw away the admin key of this validator manager and freeze freeze the things as is. And we have conducted the first audit of these contracts, and the code is already open source in this repository. If you're interested in checking it out, for now it's in BUSL license. It will transition it to BSD3 at some point in the near future. So I think Michael talked a bit about it, but what are kind of the common pitfalls that you want to avoid when you're setting up the validator manager? I think it's important to say that to avoid consensus issues, there is a limit in the churn that can happen on a validator set, meaning how many new validators can come in or how many validators can come out of the validator set without disrupting the consensus. Because if I remove 90% of the L1, probably the remaining validators will be pretty confused, and cannot perform consensus well. And so there is a churn percentage. I think by default is 20%. And so what could happen if you don't set the right weights for validators is that, you have two things actually. So you have you have the churn period seconds and maximum churn percentage, and then you have the weight to value factor, which is how much weight translate to how much stake. So for example, you can do 1-to-1. So if I stake one token, I get a weight of 1. Or you can do multiples here. So if I stake one token, I get a weight of 10, etc. And so here, this variable is also a bit tricky. If you fix it too low, weight to value factor, it means that you might lose precision and you might end up with someone staking a significant amount of token without having any weight. So, and on the other side, if you set it too high, weight to value factor, you can exceed the churn very easily, and then it will be a problem for changing validators in your validator set. And so to avoid this, basically, the simpler way is to start with big weights, because there is no downside in doing so. So if I start with a weight of 1 million, Michael, I don't know if you're, he's doing some face, I don't know. If you start with a weight of 1 million, for example, per validator, you'll have way more flexibility, as in, how much you translate stake to weight. And then, using a weight to factor close to 1, so maybe like 0.1 or 1 or 10, something like this, is a bit easier to manipulate than having very big or very small weight to value factor. And so maybe I will talk a bit about Suzaku here. So what we're trying to tackle with Suzaku is how do we help all those networks that launch on Avalanche decentralize and get connected to those operators that will make the validator set, that will help decentralize effectively at the hardware level. And we think that risk-taking is a good way of helping them achieve this. What we're trying to avoid in like new proof-of-stake networks is the early death spiral, which has been theorized by Layer, which is the security of my chain is defined by how much stake is effectively securing my chain. If the stake securing my chain strongly decreases in value, then some of my users will freak out and leave my chain. The TVL of my chain, which is kind of the main vanity metric that you use to value a chain, or like, I mean, at least for like part of the market players, will also go down, and then people will also kind of start selling because they will say, "Oh, okay, TVL dropped by 20%. It's not this token is not as good as I thought, so I was gonna sell it in churn, etc." So you could end up in a death spiral, driving both the TVL and the staking security, the actual security of your chain with it. And at the end of the day, what is at risk? It's basically the bridge TVL to the chain, especially in Avalanche, because of the way because the bridge is permissionless, right? So it's only secured by the validator set itself. There is no third party involved when you send token back and forth between Avalanche layer 1s. So if someone get access to more than 66.7% of the weight of your chain, they can send messages that will bridge out anything from the chain. And they will unlock the tokens on the C-chain side, basically, removing all the TVL. And so what you want to avoid is, going below control of 66.7% of the total weight. And this is easier to do if you have more than one player involved in your L1. For example, here today you launch an L1 on AvaCloud. I'm sure it's super secure, but you never know. It can also be social engineering. I mean, someone can get control over an engineer in your team. They get the validator keys, and they can just move out all the bridge TVL to it if it's more than 66.7%. So what you want to do, like at least to secure your network in some ways, to have more than 33.3% of your weight operated by other people, in case. So there is no single point of failure, right? And so this is what we want to help people do with Suzaku. Using the balancer validator manager, we help them smooth transitioning from POA to POS and introducing those node operators that will help you secure the chain better against this TVL risk. And we can do that using both staking of the L1 token as well as restaking of blue chip tokens for extra security and more stable security. Yeah. So I think I'm out of time. So if you have some questions, I can take maybe one.
Sorry, I didn't know I needed a mic. What's the best approach, or a common approach, standard approach, I guess, for launching a new chain, native token or ERC-20 token? And one of the concerns we have is liquidity for our new chain and getting value into our chain early on. I'd just like to understand that better.
Yeah, I guess there are multiple things. So what I talked about is mostly about on the security side of things. As I said, if you're like an early stage network, it's easier probably to set things up on the C chain. And in this case, because your native token will be effectively an ERC-20 on the C chain, so you will start with an ERC-20 staking token. Now, I know that the Avalanche team is working on a way to migrate the validator manager contract, so in case you start on the C chain, at some point in the future, you still might be able to move everything on the L1 itself for more sovereignty once your network is very robust. And I would say it's also easier, also easier to bootstrap liquidity on the C chain, right? Because, well, this is where all the liquidity is. Of course, you can, try to bootstrap on your L1, but it will probably take a bit more time. Even if we have like solutions right now to aggregate liquidity around the chains like Tesseract, it's still a bit harder, to bootstrap liquidity directly on the chain, I guess.
Awesome. Any other questions? Anyone else? Awesome. Thank you, Gauthier.